Hi everyone, this is the lab navigating the Linux file system and permission settings. The objectives in this lab you will use familiarize yourself with Linux file system. In the part 1, exploring file in Linux. In the part 2, file permissions, and the part 3, symbolic links and other special file types. Okay, in the left side is my virtual machine. And requirement resource CyberOps Workstation VM. Instruction Part 1 Exploring file system in Linux. Okay. The Linux file system is one of its most popular features, while Linux supports many different types of file systems. This lab focuses on the X family, one of the most common file systems found on Linux. Step 1 Access the command line. Launch CyberOps Workstation VM and open a terminal window. In step 2, display the file systems currently mounted. File systems must be mounted before they can be accessed and used. In computing, mounting a file system means to make it accessible to the operating system. Mounting a file system is a process of linking the physical partition on the block device. I repeat, mounting a file system is the process of linking the physical partition of the block device, hard drive, SD drive, pen drive, etc., to a directory through which the entry file system can be accessed. Because the aforementioned directory becomes the root of the newly mounted file system. It is also known as a mounting point. In item A, use the lsblk command to display a block device. Okay, it's lsblk. Okay, name. Okay, size, type, disk, disk part, size 23.4G, 1M, 23.4G, 1G, 1023M. Okay. The output above shows that the CyberOps Workstation VM has three block devices installed. SR0 is the A and SDB. The three line outputs also shows partitions under SDA and SDBA. Conventionally, dev.sdx is used by Linux to represent hard drivers, with the trailing number representing the partition number inside the device. Computers with multiple hard drivers will likely display more dev.sdx devices. If Linux was running on a computer with four hard drivers, for example, it would show them as dev.sda, dev.sdb, dev.sdc, and dev.sdd by default. The output implies that SDA and SDB have driver, each one containing a single partition. The output also shows that SDA is a 10 GB disk while SDB has 1 GB. 10 GB and 1 GB in my case is 23 GB and SDB 1 GB. Okay. Note: Linux often displays USB flash driver as dev.sdx as well, depending on their firmware type. Use the mount command to display more detailed information on the currently mounted file system in the CyberOps Workstation VM. Okay, go to the mount, view, submit, okay. Many of the file systems above are out of scope of this course and irrelevant to the lab. Let's focus on the root file system. The file system stored in dev is the A1. Okay, where is dev is A1? Okay, where is dev is A2? Many of the file systems above are out of scope of this course and irrelevant to the lab. Let's focus on the root file system. The file system stored in dev is the A1. The root file system is where the Linux operating system itself is stored. All the programs, tools, configuration files are stored in root file system by default. Run the mount command again, but this time use the pip to send the output of mount to grep to filter the output and display only the root file system. Okay, cd root and ls. What is the meaning of the output? Where are the listed files physically stored? Okay, one moment please. Okay, one root. What is the meaning of the output? Where are the listed files physically stored? No. The first command changes the directory to the root directory. Okay. And the root directory is the highest level of the file system. Because dev is the one is mounted on the root directory. By listing the files in the root directory, the user is actually listing files physically stored in the root of the dev is the A1 file system. Repeat, because dev is the A1 is mounted on the root directory. By listing the files in the root directory, the user is actually listing files physically stored in the root of the dev is the A1 file system. Why is dev is the A1 not showing the output above? Because the SDB1 is not currently mounted. And manually mounting and unmounting file system. The mount command can also be used to mount and unmount file systems. As seen in step 1, the CyberOps Workstation VM has two hard drivers installed. The first one was recognized by the kernel as dev is the A, while the second was recognized as dev is the B. Before a block device can be mounted, it must have a mounting point. Use the lsl command to verify that the directory second drive is in the analyst home directory. Okay, go to copy and paste. And this command. Analyst system CyberOps desktop download support some text file txt. Note: if the directory second drive does not exist. Use the mkdir second drive command to create it. Okay. Only this command. Paste. Okay. Cannot create directory second drive file exists. Okay. Now, depending on the state of your virtual machine, your listing will most likely have different files and directory. Okay, with the ls second drive, notice that the directory is empty. Use the mount command to mount div sdb1 on the newly created second drive directory. The syntax of mount is mount options. Okay, sudo mount dev sdb1 second and paste. Is now output is proved, which means the mounting process was successful. Now that the dev sdb1 had been mounted on home analyst second driver. Use OK print home analyst. Okay, home analyst and cd second drive. And as my file lost more font. Okay. SL. Okay, lost font is here and my file. Why is the directory no longer empty? Where are the listed files physically stored? After the mount com analyst second drive becomes the entry point to the file system physically stored in dev sdb1. Okay. Issue the mount command with no options again to display detailed information about the dev sdb1 partition. As before, use the grep command to display only the dev sdx file systems. Mount grep, okay, in the ls. Okay. When mounting a file system is used as simple, make sure you change the directory to something outside of the mounting point and use the unmount command as shown below. Sudo unmount dev easy1. Okay, go to paste. And copy this part and paste. Okay, part 2 file permissions. Linux file system had built-in features to control the ability of the users to view, change, navigate, and execute the content of the file system. Essentially, each file in file system carries its own set of permissions, always carrying a set of definitions about what users and groups can do with the file. Step 1. Visualize and change the file permissions. In the topic A of item A, navigate to Home, Analyst, lab.support.file/script/ okay, and print wd Home Analyst. Go to this directory. Go with cd and lab. Okay, launch profiles. Diagonal scripts. Okay. And use the lsl command to display file permissions. ls, sorry. Uh, okay, use the ls command to display file permissions. Okay. Consider consider the sciops.mn file as an example. Who is the owner of file? How about the group? Okay, then sciops.mn. Syopsmn. Okay, is analyst only. Owner analyst group analyst. Okay. The permissions for psyops are read and write. Okay, what does that mean? The user only can write and write. The groups only can read, and the other users only can read. The owner of the file, the analyst users can read and write to the file and will not execute it. Okay, members of the analyst group other than the owner can only read the file are. No execution or writing is allowed. All other users are not allowed to write or execute that file. Okay, the touch command is very simple and useful. It allows for the quick creation of an empty text file. Use the command below to create an empty file in the /mnt directory. Empty my new file, okay. Okay, scripts and paste. Attach. Why was the file not created? List the permissions, ownerships, and content of the MNT directory and explain what's happened. With the addition of the option, it lists the permission of the parent directory, recording the answer in the lines below. Okay, go to CD and CD, sorry, and servers and copy this part. Okay, the user analyst only can read, write, and execute. And the group only can execute and read, and the other groups only execute. With the user root, with the group root. Okay, okay. The permission of MNT directory is owned by the root user with permissions. Okay, in this way, only the root user is allowed to write to the MNT folder. What can be done for the touch command shows above the successful? The command can be executed as root, adding sudo before it, or the permissions of the MNT directory can be modified. Okay, the chmod command is used to change the permissions of a file or a directory. As before, mount the dev sdb1 partitions on the home analyst second drive directory create early in this lab. Okay, go to this step. Paste. Change the second drive directory and delete the content of it. Paste. CD second drive. Okay. Okay. LS1. Okay, I have. Okay. What are the permissions of the file, my file.txt file? What are the permissions and my file? The permission is for the user write and read, for the group the same read and write, and the other groups only read. Okay. Okay. Use the chmod command to change the permission of my file.txt. Sudo chmod 665 my file.txt. Okay, with this command I can change the permissions in the file and repeat the ls show. Okay. Okay, did the permission change? What are the permission of my file? In my case it's the same, but I don't know why is modifying the left. Here in those in the node is here the same so permissions. But yes, change the permissions of the file my file.txt. So the chmod commands text permission in the octal format. In that way, a breakdown of the 665 is as follows. 6 in octal is 110 in binary. Assuming each position of the permissions of a file can be 1 or 0, 1000 thing means read and write, and execute 0. Therefore, the chmod 665 myfile.txt command changes the permission to owner, group, and older. What command will change the permission of myfile.txt to all the permissions, guarantee any user in the system full access to the file with 665 777. Okay, so chmod 777 my file. Okay. The chown command is used to change ownership of a file or directory. Issue the command below to make root the owner of the myfile.txt. Okay, so driver sudo copy and paste. And let's analyst root. Okay. Now to change both the owner and the group to analyst as the same. Note: now that analyst is the file owner, try appending to the port test to the end of myfile.txt. Okay, echo test. Okay, paste and cut. Okay, paste. Test. Okay, was operation successful? Explain yes. Analyst is the owner of the file and the permissions are still set to the 665 as before. The permissions as they are. Allow the owner and users into the root to make changes to the file. Step 2: Directory and permissions. Similarly to regular files, directories also carry permissions. Both files and directories have 9 bits for the permissions of the owner user, the group, and older. There are also 3 more bits for special permissions, setGit, setgit, and stick, which is beyond the scope of this lab. Okay. Change back to the Home Analyst Lab support files directory and issue the lsl command to list all the files with details. Okay, change the directory with this command, copy and paste. Okay, enter this command and okay. Compare the permissions of the malware directory with the mainnet service file. Mainnet service file. Okay, it's here. Compare the permissions of the malware directory with the malware. Okay, it's the same, but this part is different. So, what is the difference between beginning part of the malware line and the mainnet service line? Is the drive. The D. There is a letter D at the beginning before the permissions for the malware directory. The letter D at the beginning of the line indicates that the file type is a directory and not a file. Another difference between file and directory permissions is the execution bit. If a file has its execution by turning on, it means it can be executed by the system. Directories are different than files with the execution bit set. A file with the execution bit set is one whether a user can enter the directory. The chmod and chown commands work for directories in the same way they work for files. In the part 3, symbolic links and other special file system, you have now seen some of the different file types in Linux. The first character in each file listed with the lsl command shows the file type. The 3 different types of file in Linux, including their subtypes and characters, are regular files, including readable files, text files, binary files, programs, and image files, compressed files. Okay, regular files, directory files, special files, including block files, files used to access physically hard drivers like a mount, points to access hard drivers, character device files with C, files that provide a serial stream of input and output. Type terminals are examples of this type of file. Pipe files, P, a file used to pass information where the first byte in are the first byte outs. This is also known as FIFO, first in, first out. Symbolic link files and la files used to link to other files or directories. There are 2 types, symbolic links and hard links. Sockets files as these are used to pass information from application to application in order to communicate over a network. Okay, in the step 1, examine file types. Use the ls command to display the files in the Home Analyst folder. Notice the first character of each line are either the symbol indicating a file or rd indicate a directory. Okay, go to cd and where is okay, sorry, cd, okay, ls and cd home. Use the lsl command to display the files in the Home Analyst folder. Go to Analyst, CD Analyst, okay, ls and this command, okay. In this case it's 22 total, in my case it's 32. Okay, use the lsl command to display the files in the Home Analyst folder. Notice the first character of each line are either a DCIM indicate a file or a D indicating a directory. Okay, okay. Produce a listing of dev directory. Scroll to the middle of the output and notice how the block files begin with a B. The character device file begin with a C, and the symbolic link files begin with L. Okay, copy this command and paste here. Beginning with C, beginning with L, beginning with D. Sorry. Okay. Symbolic. Links in Linux are like shortcuts in Windows. There are two types of links in Linux, symbolic links and hard links. The difference between symbolic links and hard links is that a symbolic link file points to the file name of another file and the hard link file points to the contents of another file. Create two files by using H. Okay. Sorry. Paste. Create this file. Go to show symbolic. Okay. Command phone. Paste. Use LMS to create a symbolic link to file 1 and ln to create a hard link to file. Okay. ln target file symbolic no such file or directory. Okay, I have a problem with the directory, but sorry. Okay. Use the lsl command and examine the directory listing. Okay. File 1, file 2, hard. Okay. And notice how the file 1 symbolic is a symbolic link with an at the beginning of the line and a pointer to file 1 txt. The file 2 hard appears to be a regular file, because in fact it is a regular file that happens to point to the same inode on the hard disk driver as file 2 txt. In other words, file 2 hard points to the same attributes and disk block location as file 2 txt. The number 2 in the fifth column of the listing for the file 2 hard and file 2 txt indicates that 3 or 2 files are linked to the same inode. For a directory listing, the fifth column indicates the number of the directories within the directory, including hidden folders. In DTMF, change the names of the original files, file 1 and file 2, and notice how it affects the linked files. Okay, cat file system, cat file. Notice how file one symbolic is now a broken symbolic link because the name of the file that it pointed to file1.txt that has changed, but the hard link file, file2hard, still works correctly because it points to the node of file2.txt and not its name, which is now file2new.txt. What do you think would happen to file2hard if you open a text editor and change the text in file2new.txt? Nothing. Okay, changing the content of the one file won't change the content of the other because they both point the same node on the hard disk drive. Reflection, file permission, and ownership are two of the most important aspects of Linux. They are also a common cause of problems. A file that's the wrong permissions or ownership set will not be available to the programs that need to access it. In this scenario, the program will usually break and errors will be encountered. Okay, this is all for this lab, and see you in the next topic of the operating system basics. See you later.